Hi guys, let's take a look at this question where we have crate P with a mass of 1.25 kgs, and they also give it in the nice diagram there, that is connected to another crate Q with a mass 2 kgs by a light inextensible string. The two crates are placed on a rough horizontal surface. What does that mean? There's probably going to be some friction, all right? A constant force F of magnitude 7.5 acting at an angle theta to the horizontal is applied on crate Q. The crates accelerate, so both of them accelerate at 0.1 meters per second squared to the right. Crate P experiences a frictional force of 1.8 and crate Q experiences a constant frictional force of 2.2. 2.1. State Newton's second law of motion in words. If you've been watching my videos, we can say this in unison, right? So Newton's second law of motion states that when a net force acts on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. 2.2. Draw a labeled free body diagram. So they want the little circle. If they said force, they would have taken the block. You would have had the block. But they want a free body diagram. So they want it for crate P. So that signifies crate P. So what are the forces that are acting on crate P? Take a look at it. All right. The obvious force is gravity. All right. So the weight. Then it's on a rough horizontal surface. We have definitely our normal force there that is perpendicular to our object. Then we have tension to the right. Do you see that? There's a string to the right, so that has to be tension in that string. And then we also have friction. They said that P experiences a constant frictional force. So friction is just a tiny bit smaller than tension. So just show that there's different lengths to it, right? It's 4 marks, so there has to be 4 forces on your diagram. Okay, 2.3. Calculate the magnitude of the tension in the string and the angle theta. All right, let's start with the tension in the string. Okay, I think let's use crate P for this because it's just we have all the values that we will need, right? So we'll start with our formula F net equals to ma. What are the horizontal forces acting on crate P? Would be tension and frictional force, right? Tension is bigger, so tension is first, and we minus frictional force there, and that will be ma. Tension is the one that we are looking for, so that's going to be the unknown. They've given us the frictional force of 1.8. We know the mass of P is 1.25, and they've given us the acceleration of 0.1. Then we do our little math magic. We multiply, we take that over so that T can be alone, and therefore the tension in the string would then be 1,93 newtons. Okay, let's look at 2.3.2, the angle theta. So there's the angle. So now we're going to look at crate Q. I'm just going to write just so you can see what I'm talking about. So we're looking now at crate Q. So we're going to start with F net equals to ma again, just so you know you can get a mark there. All right. So we want theta. So we again can look at all the horizontal forces acting on Q. What are all the horizontal forces acting on Q? It's definitely tension. But what is the biggest force? It's going to be the constant force F here. So it's going, and it's also on, it is at an angle, right? To the horizontal. So it's going to be F cos theta, right? Because it's the horizontal. Then there's going to be tension in the string, going to minus tension. And then we're also going to subtract friction. So those are all the horizontal forces acting on crate Q. And there's going to be ma. So it's going to be 7,5 cos theta minus tension that we've just calculated in the string to be 1,93 and minus the friction that they've given us, which is 2,2. And that's going to be 2 times 0.1. So we do our math calculations there. We multiply, we take over, we do the inverse cos to get theta alone. And the angle theta will then be 54,74 degrees. However, they will take a range between like 54,55 to 54,78 degrees. That's going to be their range. All right. So there will be a range, but just make sure that you have your figures. You can explain where your figures are coming from. All right. So they give a range because remember you have to use the tension of the previous question. So that's why there's some sort of range. But anyway, that is the angle that you are looking for. And that is it, guys. See ya.